I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today I am going to present on water softening treatment methods. Which includes both internal and external treatments. So the topics we are covering under this category are the types of treatments and the uses of geolite and ion exchange process and advantages and disadvantages of ion exchange system treatments. So the softening of water. Why water should be softened? So the hardness of the water is due to the presence of calcium and magnesium salts as well as metal ions and phthalates, sulfates and phthalates. So these are all the metal metal cations which are causing hardness to the water. So the water softening is the removal of all these ions like calcium, magnesium and metal cations in the hard water. So the removal of these all the metal cations and calcium and magnesium phthalates is called the water softening system. So the water used for industry purpose, before its usage, it should be properly, sufficiently, it should be pure. So it should be free from all these salts and cations. So it should be therefore free from hardness, producing salts before use. Because when it was used in industry in boilers, so it reacts with there is a chance of reaction with the chemical effluent they are using or chemical solutions or solvents they are using in the industry. One more thing. And second thing is it loses loses its mechanical strength by the corrosion formed by these calcium, magnesium and sodium salts. So and there may be a chance of boiler failures. So before feeding into the industrial purpose, so the water should be properly or sufficiently pure. It should be purified properly. So the process of the removal of this hardness producing salts from water is called the softening of water. So this is the purpose of softening of water. So here the softening of the water is done in different ways. So here treatment of boiler feed water. So before its industrial use, so the should be properly treated in two ways: internal treatment and external treatment. Internal treatment includes lime soda process, geolite process and ion exchange process. So external treatment include all these three processes. So internal treatment includes geolite, colgan, sodium phosphate salts processes. So this external as well as internal treatment we are going to discuss in detail. So the first thing is internal treatment. So this is colloidal conditioning. In this process, the colloidal forming substances like organic substances like kerosene, tannins and agar-agar are added to the tanks which are having hot water. So if the water is having hot water, all these organic compounds, kerosene, tannins or agar-agar. So these compounds are added into the tank. What happens? It forms a slimy layer with non-sticky and loose deposits like sludge is formed which absorbs all these molecules or calcium and magnesium ions so that it forms a flocculent or a layer or sludge which can be removed easily by filtration. So this what happens when it was added, it forms a coat on the scale and yield non-sticky and slime and loose deposits like a sludge. So which can be removed by blow down operation. So the formed sludge can be removed easily by the blow down operation. So the next thing is phosphate conditioning. In this, it is used especially in high pressure boilers. So this phosphate condition is useful in high pressure boilers. So this by adding sodium phosphate. So what happens? The calcium chloride present in the hard water reacts with sodium phosphate, results in calcium phosphate formation followed by sodium chloride. So this can be easily removed. So three types of phosphates are administered. So sodium hydrogen phosphate, sodium dihydrogen phosphate, acidic in nature, disodium hydrogen phosphate, weakly alkaline, and trisodium phosphate, which is alkaline in nature. So these three salts are used in the phosphate conditioning treatments. So next thing is Colgan conditioning. So the Colgan is nothing but the sodium phosphate salt. So here what happens, this is the Colgan structure. So where six sodium molecules are there. So it prevents the scale and sludge formation by forming. So here the water we added will have calcium sulfate or magnesium sulfate salts. So the calcium and magnesium salts present in the hard water react with the Colgan. So what happens when it was reacted? It displaces easily its sodium ions. It have six. Suppose it is a Colgan which having six sides. So sodium ions. So when it reacts with the calcium or magnesium salts present in the hot water, it easily displaces the calcium and sodium ions. Then, so calcium, magnesium, or calcium, magnesium. So it displaces the sodium ions and results in the metal ion form. Complex anion is formed. So the complex anion is formed. So in this process, when calcium is added to hot water, it causes the magnesium and calcium ions present in hot water to displace sodium ions. So sodium ions are replaced with calcium and magnesium ions. So result in the formation of anion complex of calcium. So this was formed. So it means the complex anion is formed when Colgan ionizes. So when it was ionized means when it was dissolved in water, when it was added to the water, the calcium and magnesium ions present in the hard water displaces easily the sodium ions in Colgan. So the next step is treatment with sodium aluminate. So here when boiler water is heated with sodium aluminate, it gets hydrolyzed. So it reacts with the sodium aluminate reacts with the water, results in the sodium hydroxide and aluminum hydroxide formation. So this aluminum hydroxide is specially a gelatinous substance. So the NaOH which is formed by this reaction reacts with the magnesium chloride and results in the formation of magnesium hydroxide. These two precipitates, particularly what are the two precipitates? Aluminum hydroxide and magnesium hydroxide. These two precipitates entrap or absorb or takes colloidal impurities which are present in the water like oil drops, sand, etc. can also be entrapped into this gel-like precipitate which can be easily removed and make them to settle down. So which can be easily removed through filtration or pumping out the top layers of water. So if we see here, this is the aluminum hydroxide or magnesium hydroxide precipitate. So these are the aluminum hydroxide and magnesium hydroxide precipitate, which is a gel-like thing which traps and entraps the oil and sand particles present in the water and which can be easily and make them to settle down at the beaker or tankers. So it can be easily removed by removing the top layer of water by pumping the water or by filtration. So the mouth methods we can use for filtration. The next step is external treatment using geolite process. So the Colgan conditioning and here the whatever we used here 4 steps: colloidal conditioning, phosphate conditioning and Colgan conditioning and treatment with sodium aluminate. All these 4 involves in the internal treatment of water in industrial purpose of field water. So the next step is external treatment. This is happening through the usage of geolite. So the geolite is a sodium salt Na2Ze. So it is a geolite. So which having it having Na2, 2 salts of sodium. So it is this whole treatment happens in an apparatus. This is the apparatus which consists of a geolite bed This is the zeolite bed followed with gravel and sand. So this is an apparatus. This is the hot water which we are going to filter here from this way. It will enter into the apparatus where it enters into the zeolite bed. There it got filtered, then gravel, then sand, and then here outlet. So the softer water is obtained here from here. So what happens? Raw water is poured inside the apparatus through inlet. That then it reacts with the chemical ion exchange reactions or takes place. So the chemical ion exchange is nothing but here it having, suppose it is a zeolite Ze. So it having two Na plus ions. This is zeolite. So it having two Na plus ions. When the hot water having calcium and magnesium salts reacts with the zeolite, it displaces easily calcium and magnesium. So these two will go and calcium and magnesium will bind in the place of the sodium. So the resultant zeolite will be with calcium or zeolite will be with magnesium. So here what happens? The zeolite having two sodium salts gives up his sodium ions. It takes calcium and magnesium ions which are present in the water. So once the active sites are completed, okay, it happened, okay. Then once these active sites are completed, if you add more further hard water, it cannot displace this because it won't have sites to take up the calcium and magnesium. So here what happens? The calcium and magnesium ions cannot be filtered further. So for that stage is called the exhaustion stage. So at that time, what we have to do? We have to regenerate. Regeneration is nothing but we have to activate the zeolite or any other compound which we are using for filtration that has to be activated. This process is called as regeneration. So the exertion to activation. This process is called regeneration. So this zeolite which we are using is converted and from exhaustion stage to activate stage means we are removing all the sodium salts. This can be done by washing with the cold water. So here if the zeolite is exhausted, then we have to wash this full column with the water. Then it displaces sodium ions and the chloride present in the water reacts with the sodium and sodium chloride is formed which can be easily dissolved in water and which can be easily removed by filtration. Here filtration. If you add water, then the zeolite bed will reactivate again and then it will filter again, then the soft water will come and then it is ready for the next batch of filtering like with hard water. So the external this is the reaction. This is what we have seen. These are the sodium ions which are there on the beads. These are suppose this is zeolite. So sodium ions are there. So when hot water coming, the sodium ions present in this area will be removed and calcium and magnesium salts will attach on this zeolite. Once all the zeolite active sites are attached with calcium and magnesium, then we have to wash with the cold water. Then calcium and magnesium chloride can be removed and regenerated zeolite is then ready to use. So here the reaction is sodium, zeolite plus calcium chloride or calcium sulfate or calcium bicarbonate because we don't know which form it is present in the hot water. It may be the carbonate form. So like calcium, so bicarbonate form, carbonate form or sulfate or chloride. Whatever it may be, the calcium from these sources get attached with the zeolite, then sodium chloride or sodium sulfate or sodium bicarbonate. So depends upon the source, all these three will form. If it is a chloride compound, sodium chloride is formed. If it is a sulfate compound, sodium sulfate is formed. If it is a bicarbonate, sodium bicarbonate will form. So the exhausted zeolite, once these all the active sites are replaced with calcium, then it has to be washed with the water. Then calcium chloride or magnesium chloride will be formed. So this can be removed and regenerated by using this cold water and then once washed it is ready for the use and ready for the filtration of the another batch. So what are the advantages of zeolite process? So it is removed about, and the resultant water is about 10 ppm in the soft water, and easy to operate, and it occupies less space. Sludge and scale is not formed in this reaction, in this treatment. The process is automatic and continuous, and first thing is very cheap and regenerated easily again. So what are disadvantages? It have only two sodium ions. Because it have only two sodium ions, so it replaces only calcium and magnesium ions. So the soft water obtained by this process has excess of sodium ions. So more zeolite if we use, there is a chance of a mixing of sodium ions from the zeolite. This zeolite acts as a source of sodium ions and mixes up the sodium ions into the water. So if the hot water containing acid destroys if the water which we are using for the filtration, if it is acid water, there is a chance of destroying the zeolite bed, because in this apparatus first the water should filter through the zeolite bed, followed by gravel and then sand. So there is a chance of spoiling the zeolite bed here, zeolite, gravel and sand. So when it enters, if it is acid water, it will get spoiled. So, the bicarbonate and carbonate ions present in the water are converted as sodium salts, resulting in the alkalinity of water. Here, zeolite is a sodium salt. So, what happens? The carbonates, bicarbonates, carbonates, bicarbonates present in the water reacts with the sodium, result in Na2CO3, sodium carbonate, NaHCO3. So, sodium bicarbonate. Again, this increases the, what happens? The presence of these two salts increases the alkalinity of the water, which is not desirable, which is undesirable to use in industrial purposes. So the colored ions like magnesium and iron cannot be removed by this process. So this is the main disadvantage. So the colored ions, which are magnesium and iron ions, so we cannot be, so manganese and iron cannot be removed by this process. This is the disadvantages. So the another trending method used in the treatment of softening the water is ion exchange process. It involves two exchange columns. One is anion and cation. So this process is also called as deionization and demineralization. So the things we are using like copolymers of styrene and divinyl benzenes are using. Same principle as we are using for the zeolite, but instead of zeolite we are using the copolymers. So for anion it is separate and cation it is separate. So we are using separate columns for filtration of anions and cations. So the pictorial representation will be like this. This is a cation column. This is an anion column. So the ions produced are cation means H plus, OH minus. So this is the difference between these columns. So these contains acidic functional groups like carboxylic acid, SO3H, and exchange their H plus ions. So the continuous H plus mineral acid H plus Cl minus ions are formed. Here sodium hydroxide Na plus OH minus ions are formed. So what happens? It continuously activated with the OH minus ions. Here continuously activated with the H plus ions. So cations. What happens here? This exchange resins represented as, always cation columns are represented as RH plus, because it is loaded with H plus ions. This is ROH minus, anions with ROH minus. So the raw water which we are supplying enters into the column like this. Then after filtering all the cations, what happens? This H plus ions displaces and replace it with calcium and magnesium ions. So the salts, the calcium and magnesium salts are removed from this column. Then it enters into the anion where these OH minus ions reacts, and then OH minus ions are displaced here. If we see, displaced with anions SO4 2 minus, Cl minus, and CO3 2 minus carbonates. So these are displaced with OH minus ions, and then the water will be coming from this inlet. This is demineralized or deionized or soft water. This is the popular method which we use in the industry to feed the boiler feeds. And these quaternary, these are like the resins contain amino or quaternary ammonia or quaternary phosphonium or tertiary sulfonium groups, which was treated with the NaOH solution and becomes capable of exchanging all the chlorides, sulfides and carbonates in the water, like anions which are present in the hard water. So this is represented with ROH minus, this we here mentioned. So cation column RH plus, it's a source of H plus ions by using the mineral acid which dissociates HCl dissociates and gives H plus and Cl minus ions, whereas in anion column NaOH displaces and dissociates into Na plus and OH minus ions. So how the process of ion exchange takes place. So here the hard water is passed through hard water, means calcium, magnesium, anions, cations present in that water is passed through the column. This is the cation column. This is the anion column. Here cation exchange column, anion exchange column. So here it was acid regeneration. Mostly HCl we will use. H plus Cl minus, because it is a strong acid and capable of producing more H plus ions. So we will use HCl. Here we will use alkaline regenerator NaOH. It dissociates Na plus and OH minus. So it continuously acts as a supply of OH minus ions. So it was activated with H plus and here it was activated with OH. So the anion exchange column will be with OH minus ions. Here cation exchange column with H plus ions. So what happens when hard water enter into the column? H plus ions. So cations present in the water. What are the cations? Calcium, Ca plus, Ca2 plus, magnesium plus. These are the positively charged ions. Those are cations. It comes and sends H plus ions out and replaces their position with calcium and magnesium ions. Here same thing. Once all the cations are removed in the cation exchange column, it enters into the anion exchange column, where the OH minus ions present in this column displaced or replaced by sulfates, chlorides and carbonates. So that's how the demineralization or deionization is happening in the cation and anion columns. So the simple reactions. If RH plus, so here whatever the H plus ions present, this is the resin H plus ions plus calcium or magnesium cations, calcium or magnesium cations, then it go and attach it with the R, the H plus will be removed. See here, the H plus will be sent out. So the R2Ca, so the two active sites. So R is having two H plus ions. So what happens? The calcium go and attach with the R, the H plus ions will be sent out. So R, so two sides with calcium ions, then two H plus. Same with magnesium. So this, it go and attach with the R and H will be sent out. So magnesium plus 2H plus ions. So this is the reaction happening here. And these sulfate ions, same thing. Here ROH. So this is the resin with hydroxyl ions. When it attached with the chlorine, same thing, R will go and attach the chlorine, RCl is formed and OH minus will be sent out. Same thing, when sulfate is attached with R, then R2SO4 will be formed and OH minus will be sent out. Same thing with carbonates. Then it go and attach, so R CO3 will be formed, then OH minus will be sent out. So this is the reaction going to happen. So it is like name itself indicating exchange. So ion exchange. The ions, both anions and cations, got exchanged with the respective ions present with cations with the cations and anions with the anions got exchanged. So thereby the filtration is going to happen. So that water obtained from these columns is called the demineralized or deionized water. So once suppose these are the resin molecules. So with active sites. This is H plus ions. As we know, these calcium magnesium ions got displaced, then full of calcium, calcium, calcium. Suppose this is a cation column. So once all these active sites are completed, it cannot filter further. It cannot displace the calcium and magnesium ions present in the water further. So what happens at that time? Exhaustion. So the resin got exhausted. It can't filter further. So at that time, again regeneration has to be done over here. So the regeneration is generally done by by washing, or then by using brine solution also we can do. So that is activated by mineral acids and anion exchanges by dilute NaOH. So these exchanges can be activated by adding the mineral acid and dilute. This is for cation, this is for anion. So what happens? The sites full of calcium. When this was added, H plus ions will displace as calcium again. H plus will come into this place. Again the full the resin will be with again H plus. So the resin is again, the column is again ready to displace more calcium and magnesium ions and ready to filter further more in the hot water. So the column is washed with deionized water, and the washings calcium, magnesium, and chloride, sulfate. These are from cation column and anion column. All these cation and anion column is passed to sink or drain. So it will come. So if we see here ions, the exhaustion stage. So here the brown color indicates the active sites are completed. See, from first step to last step. So the brown color indicates it was active sites are completed, almost displaced all the calcium and magnesium ions. So only the active site is this. So when regeneration, if we start with mineral acid and sodium hydroxide, again calcium and magnesium ions or chloride and sulfate ions got drained out. Again the regeneration. If we see in the regeneration step, all the brown thing disappeared and it was, this white is active sites. So again it was ready for the filtration. So this is what going to happen in both the anion and cation exchange columns. So what are the advantages of anion exchange column? Ion exchange method. So it can be used for highly acidic and alkaline water. Both we can use. Very low hardness water will come as a byproduct. So it filters effectively. So it is very good for treating in using high pressure boilers. Especially in high pressure boilers, it is very good. Most of the industries use ion exchange columns for the treatment of water or for softening of water. So what are the disadvantages? So it is costly and common expensive chemical required. Some these chemicals has to be there, like so mineral acid, sodium hydroxide and resin, all are some costly chemicals are required. If suppose if water contains turbidity, then the active sites present on the column get blocked. So no H plus, no Cl minus, or no Cl minus, so no sulfates or calcium, no magnesium, no H plus, or no OH minus. All the resin pores will be blocked by these turbid molecules. So before feeding the water into the ion exchange columns, the turbidity of the water must be checked and it should be below 10 NTU. Once it was without checking, if you pass the water through the ion exchange column, the pores got blocked and the column goes waste. So this is what the disadvantages and advantages of ion exchange column methods. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.